Hi learners, welcome to Virtual Chemistry. This is Dr. Padmaja. How are you all? Hope you all doing good. Let us discuss today's topic, that's factors favoring lattice energy. Here we are going to do few practical problems. I will discuss different problems. Before that, let me explain briefly what are the factors favoring the formation of lattice energy. What is lattice energy? First of all, the energy that is released when 1 mole of gaseous, 1 mole of crystal lattice is formed from their corresponding gaseous cations and gaseous anions. For example, if I take formation of lithium fluoride, lithium plus in gaseous state and fluoride ion should be in gaseous state. Okay, gaseous cation, gaseous anion together are reacting and forming 1 mole of crystalline solid compound, lattice compound. In this process, the energy will be released. That is said to be lattice energy. Okay, good. Now here, let's see what are the factors favoring to the form to get lattice energy. Whenever the lattice energy value is more, the stability of these so formed ionic compounds will be more. So how can we know that? We have an equation, force. Whenever the charges are there, we can take K, Q1, Q2 divided by R. Here, Q1, Q2 are the charges of cation and anion, whereas R is the bond distance between two nuclei. Bond length or bond distance, you can say bond length. Now, you can say here lattice energy is directly proportional to the charges of cation and anion. Whenever I will tell you what is the reason. Whenever the charges are more stronger, they can these are the just forces of attraction. It's a non-directional ionic bond. Whenever the forces are more, automatically they will come together, more energy will be released, so lattice energy will be more. That is the reason why the charge of cation and anion, if both are more, automatically lattice energy will be more, so directly proportional. Second one, the R value is at the denominator. If R value decreases, means if the bond length value is decreasing, then the force, that is the bond strength, will be more. The force of attractions will be more. Automatically, lattice energy will be more. So how the R value must be? I mean the distance, or you can say size. Let us see the size. If they are bigger in size, the distance will be more. If they are smaller in size, the distance will be less. Here it is more, here it is less. That is, how can we say that? It is inversely proportional. If they are far away, the force of attractions will be less, the energy released will be less. That means if bond length is more, lattice energy will be less, inversely proportional. Similarly, if bond length is less, lattice energy will be more because they come very close, then they form strong bond and more energy will be released. So remember these two. Lattice energy is directly proportional to the charge and inversely proportional to their, you can say size instead of R, you can say size. Okay. If size is bigger, lattice energy will be less. If charges are more, lattice energy will be. Now let us solve few problems on this concept. Okay, very, very important. Let me take this slide. Okay. Now let us see these two slides. Okay. The first question here comes is, arrange the following in increasing order of their lattice energy. Let us see. What they gave you: sodium chloride, magnesium chloride, and aluminum chloride. Sodium chloride, sodium is belonging to first group, magnesium is second group, aluminum is third group. So in a period, if you see sodium followed by magnesium followed by aluminum, means they are belonging to the same period. So whenever you say they belongs to the same period, the size mean only one additional electron or additional proton is joined. So size is not that much variable. So here this size can be negligible, okay, because they belongs to same period. any elements in the same period won't be having that much size difference, and that too they are consecutive. Sodium, magnesium, 11, 12, 13. Okay. And if you take in a group, automatically there will be increase in the size. Okay. So size factor is not considerable here. Now see the charge. Sodium is a positive ion, +1, magnesium is +2, and aluminum is +2. And according to previous definition, what I told you, lattice energy is directly proportional to charge. So who is having more charge, they will form strong, they will release more lattice energy. Now who will form here? AlCl3 is having more lattice energy. So increasing order, magnesium chloride is the next one, and the least here is sodium chloride. So answer is just keep symbols. Okay. Now let's see the second question. Arrange the following in decreasing order of lattice energy. Again, they are asking lattice energy. These are in the same period, so charges, sizes are not considerable here. And let's see the anion. Anion is the same. That's L minus, L minus. So, and see the charge +1, +2, +3. So, what is the order here? Sodium chloride is having, who is having highest energy? LCl, L2Cl3, followed by magnesium chloride, followed by sodium chloride. Okay. Next, arrange the following in increasing order of lattice energy. Let's see here. Lithium, sodium, potassium. They are in one group. Lithium, sodium, potassium. This is increasing order of size. So size is a prominent factor here. And next, here it is take chlorine. So lithium chloride, sodium chloride, and potassium chloride. So anion is same, but the sizes are increasing. Whenever the size increases, lattice energy decreases. So he is having highest lattice energy in this case, lithium chloride. Lithium chloride is having highest energy, and followed by sodium chloride, followed by potassium chloride. So the order of increasing of lattice energy is this. Which one of the following is a following forms a very strong or stable anionic compound? The answer for this question. That means whenever the lattice energy is more, is releasing more, so the strength of the bond will be that much bigger, higher. So which is having the highest lattice energy out of all this? Cation is same. Anion is fluoride, chloride, bromide. Fluoride, chloride, bromide. So this is increasing order of size. Bromide is a bigger in size than fluoride. So who is having? Sodium fluoride is having highest, loses more lattice energy, followed by sodium chloride, followed by sodium bromide. Okay. Whenever the size is small, lattice energy will be more. Whenever the size is bigger, they will away from the cation. So size will, bond distance will be more. Bond distance is inversely proportional to lattice energy. That's the reason why here it is having less lattice energy or less stability. And sodium chloride is having more lattice energy and more stability. Now let us see a few more questions on this concept. Next, arrange the following in decreasing order of lattice energy. Only two they gave you. Out of these two, which is having more lattice energy. Can you answer for this question? Try to answer. In both these elements, lithium is there. Okay, so lithium has same. No need to consider about a cation. Now let's go to anion. Anion one is O2 minus, the other is N3 minus. Okay, if it increase in charge, automatically we used to have more stronger attractive forces and more release of lattice energy. So which is having highest here, this one. So this decreasing order means you say lithium nitride is having more than lithium oxide. Okay. That is the following in increasing order of lattice energy. Here again they gave you sodium, magnesium, aluminum. Okay. And all three are same. Chloride, chloride, chloride. So plus, 2 plus, 3 plus. So aluminum is having more charge, it is having more lattice energy than magnesium chloride, than sodium chloride. Okay. Next, arrange the following decreasing order of atoms. Now let's discuss about the last example, very, very important. Here, if you see the metals, sodium is having plus charge and magnesium is having 2 plus, so automatically it has to form stronger. Next, if you see fluoride and chloride, fluoride is smaller in size than chloride, so fluoride should form stronger. Both are continuous. In such cases, if both factors are affecting, then first you go for the charge. Charge, you should give priority to charge, then size. So you take this condition. Okay, sodium chloride is having less lattice energy than magnesium chloride. Okay, in this way, if they ask you any problem on this concept, you can answer easily if you can remember the relation where lattice energy generally increases with increasing charge. Lattice energy is directly proportional to charge and inversely proportional to distance or size, you can say. Inversely proportional to size, and whenever two factors are there, give priority to charge. Give priority to charge. So if you understood this topic well, and if you had any doubts, please comment down. Thank you for watching.